Hey guys, Mrs. Traver here. We're going to walk through our notes on factoring quadratics with a being equal to 1. When a is greater than 1, we'll work on those in a separate section, separate set of notes. So the whole deal here with factoring quadratics is we're starting from standard form, then the ax squared plus bx plus c, the non-factored form, and we're going to end up factoring it or unfoiling it to get to the intercept form, which is very useful, especially for story problems that we'll work out. So the main deal here, let's kind of like think about an example that starts off in intercept and go backwards to standard for a minute, and then we'll be able to come up with steps on how to unfoil or to factor. Factor is the more formal word. Unfoiling is kind of the setup of what we'll do. So let's start with an example that is an intercept form, so we can kind of think through how we got what we got. If I had y equals the quantity x minus 3, x plus 7. And notice this whole set of notes, a is equal to 1. So there's a 1 hiding right here as my a. Let's FOIL this and see what happens. As a reminder, with FOIL, we do first, then we do outside, then we do inside, and then we do last. So that's kind of the setup here. So first is x times x squared. Outside is x times 7, 7x. Inside is negative 3x. And last is negative 21. So let's see what we have. If we combine these two middle guys, because they're always going to be combined in that way, then I've got x squared plus 4x minus 21. So notice here, my a is 1. That's the same number we started off with. My b is 4, and my c is negative 21. Let's go backwards, because our goal is to start in standard and get to intercept. So we'll start here, and let's work our way backwards and see where we got this 3 and 7. Notice the 21 is found by multiplying the two numbers here, the p and the q. So if you multiply p and q, you get c. So that's big. P times q equals c. The other thing we know is that this number 4x, the b, was found by adding up the p and the q. I'm sorry, so but if you add these guys up, negative 3 plus 7 gave you a 4. So p plus q equals b. And then the a stays the same in both, which is 1 in all of these. So these are the two things we're going to have to work through. And let's start ourselves with an example in order to do that. Now this one will start in standard and work backwards to intercept. So here we go. Let's give ourselves y equals x squared plus 19x plus 90. So we know that this c came from the p and the q getting multiplied. So I like to kind of start myself up with this, and then I can fill in the last two numbers. So let's work through our factors of 90, because these two things that go in the spots have to be factors of 90. So let's kind of work through those. I know I have 1 times 90, that's lame. 2 times 45. 3 times 30. What else? Does 4 go into it? I don't think so. 5 goes into it. 5 times what? 5 times 18. 6 times something. 6 times 15. 7 doesn't go into it. 8 doesn't go into it. 9 times 10. And then we're at the end of our list there. So let's see where we're at. These are all p's and q's getting multiplied. So we've satisfied the first requirement, that p times q equals c. These are all my options. My second bit is to find a p-q combination that equals b. So let's check all our combos. Do any of these equal 19 if I added them? Well, yeah, this one does. 9 and 10. So those are my numbers, 9 and 10. And we can check. If we wanted to, we've got x squared plus 10x plus 9x. Well, there's my 19 plus 90. All right, let's do another one. If I have y equals x squared minus 16x plus 55, I like to start myself off with my setup. and we're going to look at factors of 55. So let's do that. Let's see, I could have 1 times 55. Actually, yeah, 1 times 55, or 5 times 11. And that's pretty much it. Those are the only two ones I have. And then let's see, we want to find them that add up to negative 16. This one looks good, but these are both positive. Notice there's two ways I can multiply to get positive 55. I could have positive times positive, or I could also have negative times negative. So we can also kind of make another list of factors of 55 that also include the negatives. And if we kind of think about both of these lists together, to make a negative 16, I need a negative 5 and a negative 11. So let's check it by kind of reasoning through. I've got x times x is x squared. X times negative 11 is negative 11x minus 5x. There's my negative 16. And then negative 5 times negative 11 is positive 55. Let's do another one. How about if we have y equals x squared plus 2x minus 80? We've got lots of factors of 80, but we need ones that are really close together, 2 apart. So let's kind of think through our factors of 80. I don't think that I'm going to have to start off with 80 times 1. That's 79 apart. Can you think of any factors of 80 that are 2 apart? How about 8 and 10? But not just any old 8 and 10. I need the answer to be positive. I need one of these to be negative because this is a negative 80. So either this is negative 8 and 10 or 8 and negative 10. Which one of these would add to make a positive 2? It would have to be this one, negative 8 and positive 10. So it's good to think about which setup you're talking about. If it's a negative C, then we need 1 positive, 1 negative. So the positive needs to be 10, and the negative needs to be 8. All right, let's see where we're at. Let's do one more then. This one's going to be a little bit weird. How about y equals x squared minus 16x plus 51? All right, let's think about our factors of 51. 51's pretty lame. There's only 2 factors. There's 1 and 51 and 3 and 17. And notice again, this is a positive C. So either we've got the positive or the negative. So we also have negative 1 times negative 51 and negative 3 times negative 17. And those are all the factors that we have of 51. Check me if you'd like. Do any of these combine to make a negative 16? No, they don't. None of these combine to make a negative 16. So this one, if you come up with a situation like that, be very sure that you have all your factors. And if you do, then you can come to the conclusion that this simply is not factorable. This is not factorable. Let's do one more. If I had x squared, or I need to start with the y equals. Sorry about that. Y equals x squared minus 36. Now notice right off the bat, this one looks a little bit different because there is no b term. I could think of this as y equals x squared plus 0x minus 36. And it might be nice to think of it like this in the beginning so that when I FOIL, I can think about what that middle term is. Let's see, I have a negative c. So I need 1 positive and 1 negative. See if you can figure out what those are. Should be a positive 6 and a negative 6. All right. I hope this looks good for you. We're going to continue to work on factoring quadratics, and then the next section will have a being greater than 1, which makes it a little bit trickier. I will see you next time.